f prime, and we have the top prime, which is 3x squared, times the denominator, minus the top, times the denominator prime, 2x plus 1, divided by x plus 1 to the fourth. Okay, of course I'll factor out x plus 1, and even an x squared. So x squared times x plus 1, and let's see what is left. X squared is out, one of these is out, so 3x plus 3. X plus 1 is out, x squared is out, so minus 2x. 1 is out, so we have x squared, and this is x plus 3 divided by x plus 1 cubed. Back to my table. Where is my table? So f prime is 0 when x is 0, when x is negative 3. I study the sign. There is no point in studying the sign of this. So only x plus 3 over x plus 1. In between will be negative. Here. Just here. Between negative 3 and negative 1. And then it will be positive. I'm checking. So with negative 10, yes. With negative 2, negative 2, yes, negative. With negative 0.5, yes. With 10, yes. I'll check I'll find my mistakes in a minute. So now let's plug in negative 3. So f of negative 3 will be negative 27 over 3 plus 1, 4, 16. Okay. And now I check whether my work is okay, if these two work well together. Otherwise, I'll say oops and go back. From negative infinity to negative 27, yes, indeed, it's increasing. From negative 27 over 16 to negative, yes, it is. From negative infinity to 0, yes, it is. From 0 to infinity, yes, it is. Acceptable. So now I'm going to study the second derivative. It will take me a while till I get it. So the first derivative is x to the third plus 3x squared over x plus 1 to the third. Well, let's see what we get for the second derivative. Top prime, 3x squared plus 6x times x plus 1 cubed minus x cubed plus 3x squared times 3 times x plus 1 squared over x plus 1 to the sixth. Okay. I will factor out an x plus 1 and also a 3. X plus 1 squared. Okay, so 3 is out. So I have x squared plus 2x times x plus 1. This is out, minus x cubed minus 3x squared. These two, so a 3, have to distribute x to the third plus 2x squared plus x squared plus 2x minus x cubed minus 3x squared over x plus 1 to the fourth. At least I hope something goes away. Look at that! Brilliant! Wow! I love it. Okay, so it's 0 when x is 0. And it's depends on x. Okay, so it's negative to the left hand side of 0 and positive. So opening up, down, down, inflection point, and of course local max. Okay, finally, and you could say, what did you do all this for? I need to determine the slant asymptote now. Okay, so how do I determine the slant asymptote? Divide to get the slant asymptote using long division. Okay, where is my function? Right here. So the function is x to the third over x squared plus 2x plus 1. So I have to use long division. This is from your past. That's not what I meant. From your past experience with math. A long time ago. So we divide by x squared plus 2x plus 1. X squared times what is x cubed? The answer is x. I have to go back and distribute to all three and change the sign. X cubed minus x cubed. 2x squared negative 2x squared and minus x. So negative 2x squared and minus x. X squared times what is this? Minus 2. Negative 2 times x squared and change the sign. Negative 2 times sometimes 2x is negative 4x, change the sign. And then negative 2x plus 2. And this is 3x plus 2. So what I'm saying is, the function can be rewritten as x minus 2 plus x 3x plus 2 over x squared plus 2x plus 1. This is the remainder. This is called the divisor. This is called quotient. Only the quotient is the slant asymptote, because this goes to 0. So on the table, the only adjustment I have to make is y equals x minus 2 slant asymptote. I don't need anything else. Just my table. Nothing else matters. Okay, I think I'm on 12. Yep. Good. First, I graph the asymptotes. I see 2. X equals negative 1, and y equals x minus 2. When x is 0, y is negative 2. When y is 0, x is 2. Okay. Good. After I presented the asymptotes, now a negative 3, 1, 2, 3. Negative 27 over 16 is roughly what? Negative 2, higher than negative 2. So when x was 0 was negative 2, and this is 2. So what is that? It's not negative 2, is I don't like that number. Did I do that correctly? Where's my calculator? So our function, where's my function? So negative 3 to the third, yes, that's correct. It's negative 27, yes. And 3 plus 1 is 4, yes. So 27 divided by 16, 1.675. So negative, so that's approximately negative 1.7. Yes. So negative 1.7 approximately. I don't like this at all. Negative 1.7. 1, 2, 3. Yes, that's correct. Negative 1.7 is right here. But how is it possible? I was expecting the graph to do this. And then on the other side, at 0, 0, let me use a different color for the graph. So at negative infinity 0, at 0, 0, negative infinity, so from negative infinity to that, it's correct, that's correct, that's correct, it's going to infinity. But 0, 0 has an inflection point. It's coming from negative infinity. Yes, and it does that. So that part is clear to me. Yes, and this is the inflection point, and it does that. Okay, I'm fine with that part. But I'm not fine with this one, because I expected the graph to do this. Okay. So it cannot do that. It's opening down. So let me see my calculations here. X equals x plus 3. I have to check my calculations for a second. So 3x squared, x plus 1 squared minus x cubed, and then 2x plus 1. That's correct. So I factored x squared. Yes, and x plus 1. Yes. So I have 3x. Oh, no, I'm okay. So x squared is out, so then 3x plus 3, that's correct. So x squared is out, x plus 1 is out. Yes, and minus 2x, that's correct. So then I have x plus 3 and x plus 1. So 0 and negative 3. Everything is correct. It has a local max, that's true. It's opening down, that's correct. But the point doesn't make any sense. And I put it in correctly. X negative 27. 3 plus 1 is 4, 4 squared is 16. So, this makes no sense. This would have made sense with the maximum, but not this point. I'm checking my slant asymptote again.